Okay, welcome to a short little video on mole-to-mole ratios. This is how we compare one substance to another. So what we have up here is I have a balanced equation, and it's saying that I need 1 iron oxide for every 3 carbon monoxide, and the arrow means to yield or to produce 2 iron solids plus 3 carbon dioxides. So these numbers in front of here, these coefficients, tell me how many of the compounds or molecules that we need for this reaction to occur. This is a balanced equation. Now, the ratios that I get, it tells me that for every 1 mole of iron oxide, I need 3 moles of carbon monoxide to use it up. So I need 3 times more carbon monoxide than I do iron oxide. Or it'll tell me this. I have 3 moles of carbon monoxide in every 1 mole of iron oxide. So I can rotate it around if I need to. Another one would be, what if I wanted to compare iron to carbon monoxide? So according to this balanced equation, we need 2 moles of iron for every 3 moles of carbon monoxide. And you can see I can do this with any combination from that balanced equation. And it just tells me either how much I'm going to need or how many moles I'm going to produce. But the only way we can do this is with the mole. That's the only time where different elements, different compounds, you're going to be comparing them apple to apple. So let's take a look at this example here, and it says how many moles of iron can be formed from 10.2 moles of carbon monoxide. All right, so we are given that we have 10.2 moles of carbon monoxide, and I want to find out how many moles of iron that I'm going to produce. So I'm just coincidentally, I'm going to use this mole ratio. So since we're multiplying it, since we're comparing it, then I'm going to set up my ratio with the horizontal line there. Now all we have to do is pay attention to make sure that what I'm not looking for gets canceled out and what I'm looking for stays there. And so if you notice this ratio is set up perfectly because the 2 moles of iron's in the numerator like so. And I've got 3 moles of carbon monoxide in the denominator, and that works out perfectly for my purpose because I only want moles of iron when I'm done. Since I've got a mole of carbon monoxide in the numerator and I've got another one in the denominator, that means those 2 units will cancel out, leaving me with only moles of iron. Now comes the calculator part. Remember, all you got to do is you have to multiply the numbers in the numerator and divide whatever's in the denominator. So in your calculator, go ahead and put this in. 10.2 times 2 divided by 3. And when you do that, you'll get 6.80, and that's going to be moles of iron. So that tells me how many moles of iron I would produce if I consumed 10.2 moles of carbon monoxide. Now let's do the next one. And we've got the example here, and it says how many moles of iron 3 oxide are needed to form 17 moles of carbon dioxide. So always start with what you're given, and you were given 17 moles of carbon dioxide. And this time I want to convert it to iron 3 oxide. And so I don't have one of the ratios up here, so we need to take a look at our balanced equation. I want carbon dioxide, to be canceled out. So I'm going to use this, the fact that there's going to be 3 moles of carbon dioxide. There are 3 moles of carbon dioxide produced every time I use how much iron 2 oxide, or iron 3 oxide, And you'll see that the coefficient in front of there is 1, so it takes 1 mole of iron 3 oxide to produce 3 moles of carbon dioxide. Now we look at this and you'll see that the moles of carbon dioxide are in the numerator and in the denominator. And the only units I have left now are the moles of iron 3 oxide. So now in your calculator, multiply the numbers in the numerator and divide the number in the denominator. And when you do that, we get 5.7 moles of iron 3 oxide. And that's how you do a mole to mole conversion. Good luck.